Welcome to today's webinar, Best Practices for IoT Security in the Cloud. Our presenter is John Rota. John has 4 years of experience in IoT services working for startups and AWS. He has spent much of his time helping customers get their devices connected to the cloud and building out IoT applications with their data. John is currently a software engineer on the AWS IoT service team. Today with us, we also have Daniel Austin and Ramiz Roladia will be our webinar moderators today, answering your questions throughout the presentation. John, welcome. The floor is now yours.
Thanks, Jerry. As he said, I'm John Rota. I'm a software engineer on AWS IoT, and this presentation is best practices for security with IoT. The presentation today is going to be 3 sections. The first one is going to be about 5 minutes of why security is important in IoT, the story around that. The second section is going to be what do we mean by security in AWS IoT, the mechanisms for security and what we're talking about. The last section, I'm going to go through a demo, create some certificates, create a policy, just give you a walkthrough of creating those things so you can go away from this and get started with it. So let's just jump right in. And I plan to leave some time at the end to answer some questions, so go ahead during the presentation, submit questions, and I'll try to get to them at the end of the presentation. IoT is taking normal things, normal devices, and making them smart, getting them connected to the cloud. And some examples of things like this are connected cars. We've heard of examples. Car companies like Tesla and other companies are delivering new features to customers electronically, updating them while they're just sitting in your garage. Smartwatches, some connect to your cell phone, some actually have their own internet connectivity, things like notifications, but even being able to control the environment around you from your watch. That thermostat that looks like a Nest thermostat is representing household items. There's a lot of home automation and household items that are being connected. Just giving you some cool functionality where you can control environment in your home from anywhere in the world. That the last windmill is representing industrial use cases. There's a lot of businesses that have their processes connected to IoT. Fleet tracking and asset tracking, controlling industrial processes. There's a lot of business value to be gained by having things connected and having them working together. If you take a look at this chart, you've probably seen something like this before, the projections of the number of things that will be connected. What I wanted to highlight here is even at AWS, we're expecting anything that can be connected will be. We're going to be surrounded by connected things. But connected doesn't necessarily mean smart. If you take a look at where the internet was in the early days, everyone was talking to each other, transferring files using clear text protocols. The only thing that really held it together is no one was really out to get each other. It was kind of a campus system. People were kind to each other. Obviously not the case today, and we've built security mechanisms around that. But if you take a look at IoT, especially in recent history, all the IoT protocols, you can see some application protocols for IoT there, they also are inherently insecure. There's no security mechanism like full layer security that's built into any of those. And so we need to do something about that. Even if we go down the OSI level, down to the lower levels of networking, there's nothing necessarily built into these that handle security end to end. All of them do have, or most of them have some sort of security mechanism, but it doesn't handle it end to end. So we can't really rely on just one protocol or something like that to handle it. But my data isn't sensitive. I've heard that ever since being in IoT, and people say things like, well, this is just the ambient temperature. Everybody knows what that is. Why protect data like that? And I think the answer to that question is, why are you doing IoT at all? Obviously, you're putting in plenty of resources, developer time, actual physical capital cost to buy devices and install them. There's some value you're expecting to get out of that IoT installation, and it's important to protect that value. Otherwise, why are you doing it? And I think you have to ask yourself the question, what kind of business decisions you're going to drive off of that data, and how expensive those decisions are going to be. And you also have to keep in mind that changes are always going to happen. You're going to, a best practice would be if you've got a sensor out in the field and it has a bunch of different sensor values it can capture, why not send them all to the cloud? You may realize in 9 months that, one of those values actually is important and you want to start making decisions on it. You can imagine a scenario in which you're collecting ambient temperature, and then 9 months down the road you actually realize that that actually is a good correlation for when a machine would break down. Now all of a sudden that thing that you thought maybe wasn't valuable, you're starting to make decisions based on it. And that's why it's important to, even just from the start, protect all the data you're sending, because you never know when things are going to change and you'll actually end up using it. This slide shows devices connecting. You can see they're sending data to a service. That data could be used by users, either users of your service or maybe your employees if you're managing your assets. They go into applications. That box at the top is representing things like machine learning or analytics jobs you're running on it. And then what's a little bit unique to IoT is that data not only just runs applications and is presented to users, but it can actually cause changes to happen in the real world, right? Our IoT devices are, they can actually actuate things. They can control manufacturing processes. They can cause changes to actually happen in the real world. And I bring that up because we bring in that last device that wasn't connected. If that's a bad actor type device, not only does that bad data get to your, to your users, your employees, and maybe into your machine learning things, your algorithms, but that can cause bad changes, bad actual changes to happen in the real world. Some of our IoT deployments are, like I alluded to, you're making pretty expensive business decisions on them, and it can cause changes like that, bad things to happen for that. But there's also safety critical installations as well, and that's another reason why once we can start causing changes to happen in the real world, we really need to protect that data. So really the simple goal is just a secure connection between the device and the cloud. And what do we mean by that? It's not just sprinkling some locks on this connection, right? Let's dive into what we mean by security from device to cloud. And there's three main requirements I'm going to talk through. The first is secure communications with things, and that's highlighting that securing that communication channel. Just the traditional encryption, preventing eavesdropping, things like that. There's strong thing identity. We're going to talk about authentication and how we know that when truck 3 is connecting, that's actually truck 3. There's no device spoofing that truck. And once you have a strong story around authentication and you can prove the identity of a thing, then you can start to do things with authorization and fine-grained authorization, meaning once you know exactly that this is truck 3 connecting, you can scope it to what exactly truck 3 is supposed to do, right? And there's the obvious use cases are truck 3 probably shouldn't be able to put data into truck 4's buckets, and it also shouldn't be able to maybe delete data, right? Your devices probably never really actually should delete data. And so once we can have a strong identity story, then we can start to wrap around authorization around that. And authorization applies to things, so your device is connecting what they're allowed to do, but also to people. So you'll have applications interacting with your data, or maybe you have a mobile app to control some of your home automation things. You'll want authorization stories around that too. So we'll talk about both of those. First, let's just real quick define the system we're talking about. On the left, you can see these devices. There's only 4 of them. Hopefully in your IoT installation, if things are going well, there's more than 4. They end up connecting to AWS IoT and sending and interacting that way. You're most likely using AWS IoT because you have workloads on AWS. You're using DynamoDB to store data, and maybe you have Lambda functions that process things. So from AWS IoT, you're sending that device data into those AWS resources. And then you've got users and applications that interact with that. Maybe they take a real-time data stream from one of the devices, or maybe they're just interacting, doing a list of DynamoDB things to get history from a device. And this is just an overview of what we're talking about when I start talking about an IoT deployment. So let's talk a little bit more about secure communications with things. This slide shows some just kind of hex nonsense, right? Nobody really could make sense out of what this looks like. And the truth of the matter is, to make sense out of it, it only took me just a couple seconds to download Wireshark and just open that hex data. And it was able to discern that this is an MQTT message, it's a publish message. It was a message destined to the topic foo bar, and the temperature is 83 degrees Fahrenheit. This is just highlighting that network tools are really sophisticated today, and people are using them for, obviously for good purposes for debugging, but people are also using them to try to sniff data or interact in systems they're not supposed to. So to start this conversation, the security story for securing that communication is TLS, and more specifically, it's TLS mutual auth. And let's just talk a little bit about what TLS means. When you're just a user using a web browser, you're going to go to Amazon.com and maybe do some shopping. Amazon.com presents your browser with a certificate saying it's Amazon.com. And that's just public data, right? Every single connection that comes to Amazon.com is presented with that certificate. And what's special about that is Amazon also has a private key that goes with that certificate. And that's something that's most certainly not public data. That's something that we're going to guard closely. And what that private key does is it cryptographically allows us to prove that we're the owner of that certificate. So when we're passing that certificate around the internet, we can use that private key in that connection, sign some data with that private key and send it to your web browser, and then your browser can reverse that calculation and say, okay, you are the rightful owner of that certificate. The mechanism we're using for IoT and AWS IoT is that exact same mechanism, right? Same security mechanism that we've used for protection in the internet previously. We just applied that to IoT and then added another step on the end. So in the same way, device connects to AWS IoT. AWS IoT presents a certificate, signs some data with its private key, proves that it owns that certificate. The device is able to verify that, says, okay, great, this connection is from AWS IoT. Then we reverse that. The mutual part of it is the device also has a certificate. So it sends a certificate to AWS IoT saying, I'm truck number 3. And it uses that private key and signs some data and sends it over and proves that, yes, indeed, I'm the rightful owner of truck number 3 certificate. And that now we have that identity. We know that who we're talking to. And that's the first step of building up a TLS connection. Once we go from there's other things that happen in the handshake, like negotiating session keys and what algorithms we're going to use. But at that point, we've secured the connection, and it's a TLS connection, specifically TLS 1.2, which is the highest version of the TLS spec. Since we are a new service, we were able to launch and not support a lot of the TLS cipher suites that were less secure, so we're only supporting the most secure cipher suites. And so that ends up being, that's how we secure that connection. So now we've built a TLS session, and we're preventing eavesdropping and message replays and things like that. Let's talk a little bit more about what the story is for identity of our things. I talked a little bit about certs and private keys, and just to recap that a little bit, a certificate contains, when we're proving identity, we have a public key and a private key. That public key lives in a public certificate that you're passing around as your identity. Again, that private key is the key, if you will, to this trust. It's what allows you to prove that, me presenting the certificate, I'm actually the rightful owner of that certificate. What I glossed over a little bit in that simplification of the Amazon shopping story was anybody, if you've ever done something with self-signed certificates, maybe setting up your own web server, you realize that you can create a certificate and a private key, and anybody can create those and pass them around. And what allows you to trust that certificate actually came from who you're talking to, whether it be Amazon.com when you're shopping or AWS IoT when your device is connecting, is the fact that that certificate we're passing around wasn't something we necessarily generated, right? It was a certificate that was signed by someone above us in the internet world that's called a certificate authority. And those authorities, they actually do the legwork of saying, yes, you know, almost like knocking on doors and saying, yes, you do have a business license to say that you're Amazon.com. I'm going to sign this certificate and allow you to have the text Amazon.com in there. And then when your browser gets that certificate from Amazon.com, it actually can use a root CA certificate and see that, okay, this signature is valid. Someone above, you know, in this chain of trust, someone above Amazon verified that's who they are. And I bring that up in this story because the device needs to do the exact same thing. There needs to be a piece of data called a root CA certificate on your device, and that's what your device will use when AWS IoT presents its server certificate identifying itself. Your device will need to use that root CA and verify that, you know, validate that certificate that yes, indeed, it was signed by AWS, it was signed by a certificate authority, and indeed, we're talking to the right place. So just highlighting another piece of data. In addition to a private key and a certificate, another thing on your device will need to be a root CA so you can do that validation. A little bit about elliptical curve cryptography. When I was talking through those motions of a client or a server signing some data with its private key and then reversing that on the other end to do the validation, that algorithm typically is an RSA algorithm, and that the foundation of that is it's computationally expensive. So for certain key sizes, it would take a lot of computation, you know, more than what we have in the world today over a certain amount of time. It would take a lot of computation to be able to brute force that key, and that's great, right? That proves that that's a good thing to lean on when we're using this public key mechanism. But in the IoT world, when we're talking about these devices that are constrained computationally, that becomes kind of a bad thing. It ends up being something where we're burning battery power or you know, computation time just doing the algorithm to authenticate ourselves. And I bring up elliptical curve cryptography because this is an algorithm that takes the place of the RSA algorithm and provides the same amount of security, key strength, for smaller key sizes and less computation power. And I bring it up because AWS IoT supports elliptical curve cryptography certificates for identity. And at the bottom of this slide, I show two TLS cipher suites. And a cipher suite is just a way of identifying what algorithms we're using in that TLS connection. Things like how are we going to encrypt data and what we're using for message digest algorithms. But the thing to highlight there is those two cipher suites are exactly the same, except you can see one is ECDSA, which is elliptical curve digital signature, and one is RSA. And it just shows the difference between the cipher suites, one using the RSA algorithm for identity and one using elliptical curves. And just the takeaway from this is elliptical curves are a good thing for IoT because it allows these smaller constrained devices to have the same level of security without the computation required. So we've talked through certificates and private keys and how they're used in this interaction. So great. How do you get your hands on them? How do you provision a device, get a certificate, and start to use it with AWS IoT? And there's a few different ways to do this. I'm going to walk through each one on the slides here, and I'll highlight the differences between them and why we would want to use one versus the other. And keep in mind, I'll show a demo of some of this stuff at the end too. So you'll be able to see it actually happen. The first and easiest way to get a key and certificate is there's an API called Create Keys and Certificate. And what that does is on the server on AWS IoT, we create a private key and a certificate, and then just return it in the response to that API call. And then you can take that key and certificate, put it on your device, put it on your laptop, use it right away for interacting with AWS IoT. And this is, I'll go to the next slide here. You can see this is what the API looks like when it's invoked, and you can see in the response there is a key pair. It shows here's the public key, here's the private key, and here's the certificate. So real simple, just one API call it, and you get you get everything you need, the key and the certificate back to start a connection with AWS IoT. So why wouldn't we use this all the time? That seems really simple. The first thing is the private key actually ends up getting generated on a machine that you don't own. It has to get transmitted over the network. Even though that API is TLS secured, it's still a best practice not to have the private key in multiple places at once, right? Ideally, it would be just in one place and never leave there. This API, so why do we have this API? This is a great one for, I just want to get started. Just give me a key and certificate. I'm going to be testing on my laptop. I'm not going to use this for anything, even approaching production. Just get me started quickly, and this is just a great way. In our console, it's just one click, give me a key and certificate. So great for getting started, for testing, but as you move toward a production deployment, this isn't the way that you should. This wouldn't be a best practice on provisioning a device. So then what do you do? What's the next step toward production? And what that is you're either going to generate a private key yourself, on your laptop, or some devices actually come with a crypto chip that has a private key in it already, and that would be a best case scenario where the private key never even has to be put on the device. It's only on the device and it's only lived there. And then what you do is something called a CSR. You generate a CSR from that private key. A CSR essentially is you saying, talking to a certificate authority, in this case it's AWS IoT, we're the authority for the certificates used in our service. And you say something like, I'd really like a certificate that identifies me as truck number 3. And use this public key, and if you could sign that certificate and make it valid in your service, that it would be great. And I'm going to sign it with the private key. I'm going to send some data that proves that I own the private key for that certificate. So you would generate a CSR, and a CSR is public data just like a certificate. If someone was able to get a hold of a CSR, the worst thing they could do with it is actually turn it into a certificate. But then again, they don't have the private key for that certificate, so they couldn't use it anyway. So CSRs are perfectly fine to pass around, pass to the service. And so after you generate that CSR, there's an API called Create Certificate from CSR. So you pass to AWS IoT that signing request. AWS IoT signs that, turns it into a device certificate. And then that's returned in the response, and then you can put that certificate on your device is what you're using to connect. What it looks like to do that, this is just on a laptop. I'll show a demo of this in a bit. There's the OpenSSL command to generate a private key. Here's the OpenSSL command that you would use to generate a CSR from that private key. You can see that you put in some information that you would like in the certificate when you present it to the CA. And here's what that API call looks like when you create that certificate. You can see it's create certificate from CSR. You give it the file, the CSR file, and then in the response you'll notice here's the certificate that we created, but there's no private key, right? That wasn't involved in this API call. So that's good. We've made a step. We're not passing the private key around. It's that much more secure. But one thing I want to talk to is in both of those cases, every time we wanted a new device, every time we were provisioning a device, we made an API call to AWS IoT and said, give me a new certificate, give me a new certificate. And you can imagine a scenario when you have a manufacturing line and devices are rolling by and you're stamping new identities into them that you wouldn't want to be coupled to API calls for every single device going through. And so how would we handle that? And we handle that by you're able to create your own intermediate signing certificate, so you can become an intermediate CA within AWS IoT, and that allows you to stamp out your own device certificates using that CA. Those certificates then can be used with AWS IoT, but you didn't have to have us sign them. You signed them with your intermediate certificate. So the flow of that looks like you first do an API call to AWS IoT and get a verification code. This is a long-lived code that lives as long, until you delete it. It's unique to your account. Once you get that verification code back. Then you create a CSR. When you're creating a CSR for your signing certificate, it's the same mechanism. You'll have a private key that you're going to use in signing with that intermediate certificate. You use that to create a CSR. You put that registration code you got back into that CSR, so then your signing certificate will have your unique code in it. Then you submit that CSR through an API called Register CA Certificate. That lets AWS IoT know that we're going to be using this certificate to create new device certificates. AWS IoT will take that CSR and turn it into an intermediate signing certificate. And then you bring that back and put it into your process. And now you have what you need to create device certificates on behalf of AWS IoT. And so then what it looks like to provision a device is we've got our device again with its private key. Same mechanism. We're going to create a CSR with that private key. We're going to submit it to our own process and sign it with our intermediate signing certificate. That creates a device certificate that can be used with AWS IoT. And then we'll put that certificate on the device. And then now the device can actually connect to AWS IoT using that certificate that we signed ourselves. But one thing that inherent in this transaction that we do have to do in this case is we still need to register that certificate with AWS IoT. So in this case, manufacturing line is running, we're stamping out new identities. At the end of the day, maybe in some off time, wherever you have it worked into your process, you would just make a call and say, AWS IoT, I stamped out these certificates. Here's a list of the certificates I've made that watch for these devices to connect, that they're valid in the system now. We've talked to customers about this. One of the things that drove us for this feature was talking to customers about how they would do manufacturing. We talked to iRobot, and they said it was necessary for them to decouple their manufacturing line from creating these identities. And so that's what drove us to do this feature. And you can see that there's customers we already have that are using this in their manufacturing. So you'll notice we still did, even though we made it asynchronous, we still did end up having to call to the service for every certificate. We had to register each one of those certificates. And wouldn't it be great if we didn't have to do that? And there actually is a mechanism to handle that called just-in-time registration. And what that means is you can create device certificates with your intermediate signing certificate. And then on first connect to the service, before ever seeing it, AWS IoT knows to use that certificate and knows to provision it at that time. So just in time, that certificate is made valid in the service. And what that looks like is, let's suppose that we've created a device certificate using our intermediate signing certificate. That device has never been seen. We haven't done a register call, and it connects for the first time. And when that happens, when it connects to AWS IoT for the first time, two things are going to happen. The first is we're going to disconnect that connection. And we do that because at that point, we don't know what policy should be applied to that certificate. We know it's a certificate that we should honor, but we don't know if you want it to be active or not. We don't know if it should be able to connect or not, or publish to what messaging topics. We don't really know the usage of that device, how it should be authorized. And so the safest thing to do in that case is just disconnect it on first connect. But then what we also do is we emit an event saying we see a new certificate that we haven't seen before. And what that allows you to do is hook into that event and then run whatever you need to do to provision that device. So things like, here, I'm going to apply a policy to that device. It should be able to do these actions. I'm going to activate it because it's going to start in pending activation. So you can do things like activate the certificate on that event. Maybe you want to do some things like some bookkeeping things around it, like create a thing for that certificate, or update its shadow. If you know AWS IoT, you can have shadows that are states of devices. So you could do something like, here's its initial state. And so in that case, then after we've done those things, then when the device connects for the next time, it's all set up and provisioned in the service. And so you'll notice from the manufacturing line, we didn't have to do anything to register that certificate. It's all handled on first connect, and we give you a mechanism for wrapping some automation around that. This slide is meant to highlight that device manufacturers are getting better and better about adding security features right into hardware. There's things like enclaves for storing private key data. There's things that they have cryptographic modules that accelerate these calculations. So things, even doing things like RSA factorizations are done in hardware on a dedicated chip rather than on your microcontroller, so I'm not consuming cycles from you, but done efficiently in a chip. This is just highlighting that hardware manufacturers are making these things easier as you move to production. So let's talk a little bit. It said, boy, we're gonna keep that private key secret. What does that mean? What do I mean by we're gonna keep it secret? This first slide shows maybe you're in a test environment or just developing your laptop. Maybe that's just as simple as just making the file not world readable, right? It's not going to be used in a production environment. You don't expect people trying to use that certificate or take over that device when it's just your laptop. So maybe security in that case of protecting that key is just make it not readable to the world. As these devices migrate out of your control and they're used in the real world, they're going to face more challenges than what they would just internally. There definitely are documented cases of of hardware hacking, if you will, where people will take apart a device and try to extract key data from it using debuggers. And so there are definitely protections you need to place around a private key as it leaves in your device out in the world. There's software protections. If you're in a Linux world, there are ways to do jails or security enhanced Linux to further protect that file from access. If you're on hardware where you have dedicated hardware for that, there's things like trusted platform modules that have private key data inside of them, storing them out of the view of other processes. There's things like one-time programmable memory where you can put key data in and not be able to extract it. And only be able to do some of this hardware has things where there's a private key inside of it and you can't actually, there's no verb in the hardware API to pull the key out. You only can do things like sign data with it, so that private key can't be extracted. This is just highlighting that as your devices go out into the real world, you need to take more precautions against protecting them, and here's some examples that you can research on, things that would make sense for your use case and what you see as your threats. I've gone this far without bringing up probably one of the most important best practices of security in AWS IoT, and that is each device should have its own identity. And I'm guilty of this in testing of sharing a certificate across a couple devices. But definitely when you move toward production, a best practice is to have each device have its own identity. And where that becomes important is when you end up having some sort of compromise of a device. If you're sharing that identity across multiple devices, the blast radius is pretty high. If you have to disable your entire fleet because one device was compromised, that's bad news. And if you have one certificate or one identity for each device, then you limit that you limit that effect to just being able to disable that device and revoke that certificate. What it looks like to revoke a certificate is, you can see here we listed our certificates. You can see this one is listed as active. There's an API call that can update it to say it's revoked. Now you can see it's revoked, and that certificate is no longer honored when connecting. And again, if this was one device, we just disabled one device. If the certificate was shared across multiple devices, then we just disabled potentially a big part of our fleet. So best practice, definitely one certificate per device in production. So takeaways from strong identity. There's many methods of provisioning. We're making it easier for manufacturing by doing just-in-time things and being able to be your own intermediate CA. Definitely a best practice is every device should have its own certificate. And I just mentioned that you can use a certificate authority for offline provisioning, so you don't have to be connected to the internet to make new device identities. So now that we've built a story around authentication, what are we doing for authorization? What does that look like? First, for things, whenever something connects and presents a certificate, there's going to be a policy associated with that certificate, and that policy describes the authorization story. It describes what actions it can take, what resources it can act upon. The verbs we have in policies are things like, can it connect or not, can it publish or not, and to what topics. unsubscribe, that seems like a pretty insidious way of attacking a device, is connecting as it unsubscribing and then disconnecting, and then now the device is no longer getting messages. It'd be pretty, I'm sure there are use cases, but I think it would be a rare use case for a device to be to unsubscribe to maybe its messaging topic, so we allow you to limit that. And then receiving messages. And what a policy looks like is you list out, it looks just like policies you're used to in AWS. You specify an action and then a resource for that action. So this particular one says allow this device to connect, and allow to connect is this thing name. This is the client ID in MQTT. So whatever this is applying this policy, whatever is using this policy, can only connect as this device. You can use wildcards in these policies if you maybe want to apply the policy and open it up a little bit, apply it to multiple devices. You can do things like wildcards. Here's an example of what a publish policy looks like. You can see a topic, and then the topic specified as an ARN. You can do even finer controls. You could do something like this, and then publish to just one topic, and then have a rule in AWS IoT that only updates a specific part of a document. So this is an interesting way to use the rules engine to have finer grain access. Takeaways for thing authorization are topics can be structured for permissions. Definitely make policies a security best practices, making policies as restrictive as they need to be. You can use wildcards in policies if you want to open it up a little bit more, and there's an interesting use case for using rules to make it even more fine-grained. Now let's talk about what authorization looks like for people when you have people or applications interacting with IoT. The first use case is going to be an application. Maybe you have a web app or a client app you've developed and it's going to interact. Those same policies can be used in identity and access management policies in AWS. So just the same kind of policies you would use to restrict users for DynamoDB or something like that. You can use the same thing for AWS IoT nouns and say things like allow to publish or allow to subscribe. So it's the same thing that you're used to in other policies in AWS. For the mobile use case for users, there's a product called Amazon Cognito, and that's a way to vend temporary AWS credentials to things like mobile apps, so you don't have to put AWS credentials into your apps. You can just make an API call and get some short-lived credentials. Those support the same sort of policies as connect and publish, and then you can actually, so this is what Cognito supports. You can then you can scope those down further and add an IoT policy to them, so you can scope down what your mobile app can actually do. I'm going to skip over this slide. It's just talking through the pairing workflow for Cognito. To highlight this is, the highlight of this slide is, this applies to authentic Cognito users. If you're aware of Cognito, you can have unauthenticated users and authenticated users. I think the key point of this slide is these policies only apply when the users are authenticated. Managing fine-grained permissions can be hard, and so there's ways of adding wildcards. So you can put in wildcards and have open those policies up also in Cognito. Takeaways from authorization for people are same IAM roles and policies you're used to can be applied to IoT. Cognito is the service to use when you're using a mobile app and you have humans interacting. IoT scope down policies allows you to scope it down to the topic or the device connecting. And there's ways of using naming conventions to make it simpler. You can do things like wildcards to simplify the management. So now we're going to jump into the demo. I'm going to demo creating certificates in a few different ways, and also demo creating a policy, and then I'll show you a just-in-time registration example. All right, so this is the AWS IoT console. You can see I've got 3 certificates here. I'm going to refresh the page here just to make sure we're starting from scratch. And the first thing I'm going to do is go through that one-click creation of a certificate. What does it look like just for the, that simple interaction? And I'm going to go to create a resource and then create a certificate. You can see on this page we're presented with, here's a button to one-click create, so I'm just going to click on that. And in the background on the server, it created a private key for me and a certificate for me, and then it presents me with the links where I can download those. So I can just pull those certificates and keys down to my computer and use them. One thing to highlight from this too, when I talked about private keys, this is the only place that you'll be presented with an ability to get that private key. In order to follow best practices for security, if we're creating private keys for you on our service, we're not going to log them, we're not going to store them. This is the only time you would have access to them. And so keep in mind that going forward from here, after I close this page, there's no API call I can make to say, give me that private key again. And so that's just something to highlight when you're creating it this way. Go ahead and download these and use them, and you won't be able to get the private key again. So now you can see here I just created this one. It's inactive. I could click on this and activate it, apply a policy to it, and use it. But just one click, I got what I needed to connect to AWS IoT. The second way I'm going to do this, I'm going to show you what it looks like to create a CSR. I'm going to have the private key just on my laptop and not actually send it to the service. So the way we do that, I'll go over here and I'll just enter, here is the OpenSSL command to make a private key. So let's just do that. And you can see now I've got my private key. Here's the command to generate a CSR from that private key. Here's where we enter information on what we want to have in the certificate. I'm just going to make some stuff up for now. And you can see now we've got our private key and we've got a CSR that corresponds to that private key. And so now I'm going to invoke that create certificate with CSR API call by just going to the same certificate create page. And then you'll notice over here there's a button that says create with CSR, and it's got a little upload arrow showing that we're going to upload CSR. So I'll click on that, click on my CSR. And then when I say upload, it says, I've created your new certificate. And at this point, you might say, well, wait a minute, where's the link to download that certificate and private key? And the first thing to say is, you'll notice we never actually ended up having to send the private key. That wasn't part of that transaction. And then when we go down here and we click on the certificate we just created, you can see that there is a link that this is how we can go and download that certificate to use it. And so in that case, we never ended up having to transmit the private key. We were able to just submit that CSR and then download the certificate later. So that shows the two ways of creating it that way. Now I'd like to go through the just-in-time example. Before I do that, I'm going to clean these up. And now you can see we're back to 3 certificates. I'm going to go over here really quick. I'm going to connect. This is an MQTT client in the console, so I'm going to connect and I'm going to subscribe to that event topic where you can see where we emit the event when a new device is seen. So I'm going to subscribe to that event topic, which is and subscribe. Let's go back here. You can see I only have 3 certificates in my account right now. Let's go back to the certificates page. And then I'm going to go out here, and what I have out here is a simple example I created with our embedded C SDK, and this is going to connect with a certificate that I had created. I created the certificate with my intermediate signing certificate. I've never registered it with AWS, and now when I connect, you're going to see this is going to happen fairly quickly, so I'll describe it a little bit before I do it. When I connect, we're going to go back to that MQTT client. You'll see a registration event be emitted. That's how you could hook in and put some automation around this. I haven't put in automation for this, so what I'm going to do is I'm going to go back to my certificates page, and I'll see a new certificate. I'll see the 4th one show up here. That certificate is going to be created in the pending activation state. So I'm going to click on it and activate it. And then I'm going to apply a policy to it that says allow that device to connect. And over here in my terminal window, the first thing you'll see is the device is going to try to connect, and it's going to be disconnected. I had talked about how that flow works. And so then I just wrote this sample to just wait for 10 seconds and then try to connect again. And hopefully if I'm handy with the computer, I'll be able to activate that certificate and apply that policy. And then in 10 seconds when this tries to connect again, you'll see it connect successfully. So let's go ahead, let's go back to the MQTT client. We're still waiting for those registration events. I am going to run that sample. There's our registration event. Go back to my certificates page. Here's my pending activation certificates. I'm going to go ahead and activate it, and then I'm going to attach a policy to it that allows it to connect. And now it's active and it's been registered with the system. We'll go back here. You can see there it was. My SDK was disconnected because that certificate wasn't active, and now it goes through that reconnect loop, and now it's connected. And we can go back here. Let's go back to our MQTT client just to prove that we did that. Let's just let's publish a message to that application. So. And now you can see it's connected, it's interacting with the system. So in that example, we took a certificate that had never been seen by AWS IoT yet, connected, we applied a policy to it, activated it, and now it's interacting as a device without intervention. So now we can go back to the slides. And let's just wrap up, do a summary of what we talked about, and then we'll open up to questions. Right. Highlighting what we went over today, we talked about secure communications with things, how we secure that communication channel, what TLS means, what that handshake looks like. We talked through strong thing identity, so how do we prove that when our devices connect, we know each device and it's only that device. Once we have that identity, we've shown that we can build authorization around it, and that authorization applies to our things as they connect, but also to people as they interact, so applications and maybe mobile apps from users. And that's it for today. Thank you so much for attending the webinar. I have some links here for where documentation can be found. There's one link there at the bottom is the AWS IoT forum. This is a forum that engineers on the service team actually answer questions. So if you have questions, that's a great place to get answers. And then just the AWS IoT landing page at the top. And now we'll open up for some questions.
Well, thank you, John. Thanks for the great presentation. And Danielle and Ramiz, thank you for engaging the audience throughout the presentation with our Q&A. On your screen, you'll see our live poll questions. You'll see 3 at the bottom, and there's 1 at the top of the screen for more feedback. You'll also see on the left side of the screen the Q&A pod has been moved over there. So feel free to put your questions.
As a security cache. We actually have looked into that. It's still certainly early days for a technology like that, but that's definitely an interesting application of having some sort of peer trust to build out an authentication story for IoT devices, especially when they're out in the field. They it's maybe an easier interaction for them to talk to their peers rather than a central service. So certainly have started to think about things like that, but it's still really early. One of the questions says, what is the cost implications for applying certificates at scale? One thing I can highlight there is There is no cost associated with provisioning certificates. You can provision as many as you use in your account. One of the reasons we chose certificates and us being the CA is being able to apply that and scale that to the same, the same number of devices we expect in IoT. So there's no per cost use of using certificates. All right. What else do we? Okay, here's one. Like to hear about anti-malware and antivirus software for use on AWS Cloud. Typically something like that. We run the security story of our services in the same way that any other service AWS presents. There's no specific application, and there's no uniqueness of IoT when it comes to anti-malware software or virus software. There's more information on security practices for AWS on the AWS website. As far as software that could be running on devices that's kind of application specific, certainly if your device was running an OS that was susceptible to things like that, you would have to do a security review and see, are there ways that any kind of malware would get onto a device. Typically devices like this aren't susceptible to things if they're not a general purpose OS. They're not as targeted as highly, but there definitely are. If you do searches, you can see companies that help with security posture for devices. Could help recommend software if that was applicable for that use case, but there's no real general guidance we have for something like that. It looks like there's a question. Are CA certificates in AWS IoT free? And yes, they are. You don't pay for creating your own intermediate signing certificate. This question elaborating on establishing that you're the owner of the private key after you send the CSR to AWS, after you generate your own cert. Let me take a look at that again, in case you generate your own cert. I'm going to assume that means when you create your own signing certificate. In that case, it's the same, that same mechanism. Your signing certificate would have a private key. When you create a CSR, you use that private key that's part of the transaction that happens when you create a CSR. And so that's when you register that CSR to be used as a signing, or that intermediate certificate to be used as a signing certificate in AWS IoT, you would use that private key, and that's how we determine that we're able to sign that for you. And it looks like that's the last of the questions for today. Thank you so much for attending.
I'd like to extend a special thank you to your presenter today, John, for his time and the great presentation, and to Daniel and Ramiz for the great answers for our Q&A questions. If you have any comments on our previous or upcoming webinars or suggestions on the topics you wish AWS to cover in future webinars, please feel free to email at aws-webcasts@amazon.com. Your feedback will help us to improve our webinar programming. Thank you to our audience for taking the time to join us today. Enjoy the rest of your day.